Welcome, children, to the first chapter in physics, motion, describing motion. In everyday life, we see objects at rest and in motion. Birds fly, fish swim, blood flows through our arteries and veins. We often perceive an object to be in motion when its position changes with time. However, there are situations where motion is inferred through indirect evidences, like if there is air flowing or air moving. How do you understand that the presence of air? It is by the movement of leaves or branches or the clothes that you have let for drying. An object may appear to be moving for one person and stationary for the other. The classical example of a moving bus. The bus is moving, the road and tree appear to be moving backward. A person standing on the roadside perceives the bus and the passengers as moving forward. And if you are sitting inside the bus, then your fellow passengers are at rest. So motion is little complex. Some objects move in straight line, others may take a circular path. Some may rotate and some may vibrate. There may be situations which can involve all these together or combinations. In this lesson, we shall study and describe the motion of object along a straight line. And we will express the motion, types of motion as equations and graphs. So we will define motion when an object changes its position with respect to its surroundings and time. Examples: moving car, buses, train, cricket ball, planets revolving around the sun, molecules of gas in motion. An object is said to be at rest when it does not change its position with respect to its surrounding and with time. Examples: mountains, buildings, etc. Rest and motion are relative terms. An object which is at rest can also be in motion simultaneously. Just like the example I described previously, passengers sitting in a moving train are at rest with respect to each other, but they are in motion with respect to the objects like trees, buildings outside. Let us see what is distance. The distance traveled by a body is the actual length of path covered by it, irrespective of the direction in which the body moves. Let us look at this example. A person is traveling 5 kilometer distance first in a direction, and then he is moving a 2 kilometer distance in the upward direction. The total distance traveled by him will be 5 plus 2, which is 7 kilometers. A person is traveling 5 kilometers in the forward direction, and then he returns back in the same path and covers another 5 kilometers. The total distance traveled by him is 10 kilometers. 5 plus 5. Let us study the concept of displacement. Displacement of a body is the shortest distance between its initial position and final position along with direction. Let us imagine a person is traveling around 4 kilometers towards the east. Then he goes 2 kilometers towards north. Now what will be his displacement? It is the shortest distance from the initial point to the final point. Now let us see a person has traveled 5 kilometers towards east and then come back along the same path to the starting point. The displacement in the first case is going to be the shortest distance, which is 4.47 kilometer, whereas displacement for the second case is going to be 0 kilometer because it is the shortest distance from the initial point to the final point. So displacement can be 0, distance can never be 0. Let us see the differences between distance and displacement. Distance is a scalar quantity. Displacement is a vector quantity. Distance traveled by an object cannot be 0. Displacement of a moving object can be 0. Now let us see what is a scalar and a vector quantity. Scalar quantity is a physical quantity which has magnitude only. It does not have direction. Like for example, length, mass, time, speed, energy, etc. They have got measurable values, but they do not have direction. They can be in any direction. Vector quantity has got specific direction and magnitude. Like for example, displacement, velocity, acceleration, momentum, force, etc. Let us study about speed. Speed is defined as distance traveled by a body in unit time. Speed is distance traveled by time taken. If a body travels a distance of s in time t, then its speed v is given as s by t. V is equal to s by t. Speed is a scalar quantity. Speed is either positive or zero but never negative. Speed of a running car is measured by a speedometer. Speed is measured in centimeter per second, meter per second, or kilometer per hour. Now let us see what is a uniform speed. A body has a uniform speed if it travels equal distance in equal intervals of time, no matter how small these time intervals may be. Let us look at this car. It is moving at equal distance in equal intervals of time. Uniform motion. A body has uniform motion if it travels equal distance in equal intervals of time, no matter how small these time intervals may be. So, a body moving with uniform speed is also in uniform motion. Variable speed. A body is said to be moving with variable speed if it covers unequal distance in equal intervals of time. It is called non-uniform motion. Look at this car. It moves at a non-uniform motion, that it's speeding up and then it stops. What is average speed? Average speed of a body is the ratio of total distance traveled to the total time taken to cover this distance. Total distance traveled by total time taken is called as average speed. V average is equal to distance traveled total by time taken total. Let us see an example. A car covers 25 kilometers in the first 1 hour and 35 kilometers in the next half an hour and 30 kilometers in the last 1 hour. Then the average speed of the car is 25 plus 35 plus 30. The total distance covered by it divided by the total time, 1 plus half plus 1, which is equal to 36 km per hour. So hope you have understood the concepts dealt with today. Please go through them again to